Alright, this video will be going over the Linux portion of the ICMP lab, and same disclaimer as before. If you're watching this in the future and we're doing a remote version of the lab or some other version, some of these commands might be different, but some of them might be the same. So we're just going to run through these commands and see what happens. We're looking for what was sent by the host when we run these commands, and we're looking for the response from the target that we receive when running these commands. So before we even start, would like to point out that I am running as root to run these commands. Some of these commands require root privilege, so if you want to become root, if you did not log in as root, you can use sudo-s and that will make you root, or you can stick sudo in front of the commands as you're running them. And if you watched the Windows video, you saw that my Tiger VNC session was being somewhat unreliable, and it's still being somewhat unreliable, and I still don't feel like fixing that right now, or trying to fix that because I need to make this video. So we're going to try to live with it for the time being. So if we look at the lab sheet, the first command is to do a trace route 100, 100, 102. So we'll run that. If you recall from the Windows portion of the lab, the trace route was sending out packets with low time to live values. I don't know if you remember, Windows went kind of slow. So that did all four of them pretty much instantaneously. And if we look at what happened over here, the Linux trace route works a little differently. It works a little differently, and it sends out a bunch of packets all at the same time. So it does the same thing. If we look at these packets, in the IP header field, time to live field, we have a time to live of 1. If we look at the next one, it's going to send out 3 packets with a time to live of 1. The time to live is 1. And then this third one will be time to live of 1. Try to make this faster. Yeah, time to live of 1. And then the next set of packets will be time to live of 2. So it sends all these at once at the beginning without waiting for any replies. I guess it makes some assumptions about how big the network might be. So this has time to live of 2. And the other thing to note is this is sending out UDP packets, whereas with Windows we send echo requests. With Linux we're sending out UDP. So then we're looking for the same time to live exceeded error messages to come back. So here we have time to live exceeded from 10.243, 133.33. That's our first hop. 192, 168, 243.254. That's our second hop. And then 100, 102, that's the final host we're trying to connect to. And in this case, we're getting host administratively prohibited coming back, which that is happening because the firewall is running on that host. I'm going to run the command again. I'm going to turn the firewall off and then run that command again so we can see what the difference is, because I like looking at stuff like that. So we'll run it again. We did the same trace route. We got the same results in the thing. And if we look, I'm going to go ahead and stop this. We got the same results in the thing. We got the same results in the terminal. If we compare the results, they were the same. Our packet's still taking the same route. And if we look at the output in Wireshark, we had a similar behavior. We sent out a bunch of UDP. We started getting the time to live exceeded messages. The time to live exceeded messages. But then the difference with the firewall off is now we're getting port unreachable messages. So we learned about the transport layer last week, and one of the things we should have learned that is if you send a UDP packet to a port that is not listening, you will get back a port unreachable message. But like I said, the firewall was running before, which was why we got those administratively prohibited messages the first time. So you want to save this, capture, save it for submission. Yeah. All right. That's the first one. I'm going to restart my capture. I'm not actually going to save it. You need to save it. And then I'm going to go to my lab sheet and see what the next step is. Okay, so this is one where we definitely need to have run as root. HPing is a tool that lets us send arbitrary packets. In this case, we're going to send a UDP packet to port 99 -C1. We're going to send one packet. That is a 1. There's a space there. And then we put the IP address of this host. I did not turn the firewall off, so I don't know if it's on or not at this point. So we'll have to see what happens when we try to run this. Hopefully it's off. So the command was hping --UDP -P99 for port 99 -C1, and then the IP address. So we're sending one packet to port 99 that's UDP to this host. So let's go look at what happens in Wireshark. Oh, and we did get the administratively prohibited, which means that the firewall is on, which is not the behavior we wanted. So this is what we sent. We sent one port 99 packet to that host. It's UDP. Wireshark decodes. Never mind, that didn't happen this time. All right, it's perfect. So you will not get that result when you run in the lab because I will turn the firewall off. What you will get will be destination port unreachable, which we just saw when we ping 100, 100, 102 with the traceroute port. So, yeah. All right, why don't I go turn that firewall off real quick so that we can get the expected results. That's always a good thing to do. I was typing in a window you can't see. Haha. All right, did I leave this running? Let's try that again. Yeah. So this time we got destination port unreachable, which is what you should get in the lab. So we sent the same port 99 packet, but we got port unreachable because that port is not listening. The firewall is off now, so it should be off when you get in the lab. If not, let me know, and I'll turn it off. So next we have another hping command. This is going to send a timestamp request, which is an ICMP thing that's not really used anymore for anything useful. So let's go ahead and try that one. So it was a, let me restart. Make sure you save and stop and save your capture file. Stop. You want to save it. You want to restart. All right. So we're going to run a similar hping command, but we're going to change it up a little bit. So we want to do, instead of UDP and doing a port, we're going to do ICMP-TS. Sometimes students get stuck on this bit here. That's dash dash. Those are two dashes in front of timestamp, ICMP-timestamp, and UDP from the previous one. So we go look at our capture file. We send a timestamp request. Stop it, save it. We sent a timestamp request. So if we look at what was sent, if we go to the ICMP protocol portion of the packet, we sent a type 13 code 0 timestamp request, and the reply was a timestamp reply. So it's another thing that's not really used much, but we wanted to see as much ICMP as we could this week. So the reply is type 14 code 0. All right, the next one we're going to send this complex command. I'll explain that when I get to it. So save this, start another capture. So this one we're going to do hping -0, which 0 is raw socket mode for the hping command, which lets us pretty much arbitrarily create packets. We're going to do -H9, which will set the IP protocol field to the number 9. And my window died again, so we'll bring that back. So -H9 is going to set the IP protocol field to 9, and we'll look at that once we send it. And then we want to send one of those to 192.168.240.102-C. Yeah, continue without saving. That's what I wanted. -C. What's going on with my terminal? It's very weird. I got to figure out why this is misbehaving before we make it farther into the class, because we might need this later. So I want -C1 and then 192.168.240.102. So if we send that, look in Wireshark, it shows up as a malformed packet. It does that because Wireshark is expecting this to be an IGRP packet, which is like Interior Gateway Routing Protocol. Wireshark expects that because we told it put 9 in the IP protocol field, but then we did not specify any kind of payload for this packet. So Wireshark's like, you said that it says that it's IGRP, but it's not IGRP. So that's what we sent, and the reply we got from that was destination unreachable, protocol unreachable. So hopefully you notice we got a bunch of different destination unreachable messages, and then in order to know why it was unreachable, we had the other part of the answer. So we had type 3, which says destination unreachable, and code 2 was protocol unreachable. So I believe that was the last one on the lab sheet. So those are the, no, there's one more. It says change the IP route on your router, take the old one off and add a new one on the router to point to 192.168.243.1. So you'll go onto your router and do no IP route 0.0.0.0, 0.0.0.0, 192.168.243.254. And then you will add a new route. And then after you do that thing, you will run this command. And then something will happen. So I'm going to go. All right, I'm using a virtual. You will not. All right, I'm going to go do something real quick. Actually, I'm using a virtual router, so the interface is going to look different than what you will see if you look at my interfaces. But this is basically what we need to do. So right now we have a default route to 192.168.243.254. You need to get rid of that. So no IP route 0. So that'll get rid of that route. So do show IP routes. So now I don't have a default gateway, and what I want to set my default gateway to is .1. So these are the steps you'll need to take on your router for this part. So now I have changed my route. So now I can go run that last command, that I need to run, which is sending ICMP. This -X is going to tell it to set the more fragments flag, which if you remember from our fragmentation learning, the more fragments flag is how the other host knows that more fragments are coming. Let me look at that command again. Yeah, so that's what we're going to send. And this one is a little tricky. Almost done. We can do this. I know we can. And this one is a little tricky because what we'll do is we're going to send it, and if we look in Wireshark, we see that it went out. We have our fragmented IP protocol, but we haven't got anything back. So this one requires for a reassembly timer to be exceeded. So it takes like 10 or 15 or 30 seconds before we will get the reply back for this one. So we just need to wait for some length of time, and then we'll get the reply back. So I have it now. Time to live exceeded, fragment reassembly time exceeded. So essentially what happens in this case, we told that other host that more fragments were coming, but then we never sent more fragments. So if we look at that, type 11, code 1. And that concludes this part of the lab. So as a reminder, you should have been saving capture files throughout the way, all along throughout the lab, and you should have them to submit. So yeah. So if you're still here, I'm glad you're still here. There is a question on the midterm exam that says something along the lines of, describe an action you can take that will cause an ICMP error message to be generated. And lots of times students say things that aren't correct, like they say sending a ping. Well, if you send a ping, that's a informational message, and an echo reply is another informational message. So that is not a error message. So we have just gone through several activities that caused ICMP error messages to be sent. So you should be able to answer that question with any of these activities we just went through. Sending a packet with a more fragments bit set, but never sending the rest of the fragments. Setting the IP protocol field to a protocol number that the other host isn't listening on. Sending a ping to sending a UDP packet to a port that's not listening would be an acceptable answer. Doing a trace route would be an acceptable answer. Doing an impossible strict source route would be an acceptable answer. So any of these things we did would be, not any of them, any of these errors we generated would be a acceptable answer. Sending a big ping with the don't fragment bit set would be an acceptable answer. So that's one of the questions in the midterm exam. So hopefully if you watch this video, you'll write one of those things down and commit it to memory.